जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों तू आए ना ढूंढता हूँ थक गया पर तेरा क्यों पता न चलता सही जाती नहीं है दूरी रही होगी तेरी कोई मजबूरी पर आ जाना पास मेरे अब देखे ये सांसें हैं तुझ बिन अधूरी कब से तू मुझसे है रूठी कहती है प्यार नहीं चले झूठी तुझ बिन मैं आधा हूँ यार तू ही तो करती है मुझको पूरी तू ये जाने ना कुर्बान न पल के भी बिछा दी तेरे आने की उम्मीदों में जान भी जाए ना तू भी आए ना तू क्या जाने सोया नहीं हूँ कितने मैं महीनों में किया था तूने वादा प्यार करोगे हमसे ज्यादा कहाँ गए तुम इस घड़ी में फिर बदला क्यों इरादा सपना तोड़ा क्यों हमारा कट रहा था सब कुछ तो खुशी में तू ये जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों तू आए ना ढूंढता हूँ थक गया पर तेरा क्यों पता न चलता तू ये जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों तू आए ना ढूंढता हूँ थक गया पर तेरा क्यों पता न चल रहा अब दिन से रातों में सपनों के मुलाकातों में खुशी बस ख्वाबों में भरा वहाँ भी आती नहीं नींद से जगाती नहीं आंखों से ही तुझको है छुआ तू जो जाएगी फिर ना आएगी ना करूँ उम्मीद तुझसे कहते ना हो हम सफर मौत ही आएगी यूं सताएगी सोचते फना हो जाऊं मेरा होगा ये हशर तू ये जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों तू आए ना ढूंढता हूँ थक गया पर तेरा क्यों पता न चलता नाराना नाराना na 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 जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों तू आए ना ढूंढता हूँ थक गया पर तेरा क्यों पता न चलता सही जाती नहीं है दूरी रही होगी तेरी कोई मजबूरी पर आ जाना पास मेरे अब देखे ये सांसें हैं तुझ बिन अधूरी कब से तू मुझसे है रूठी कहती है प्यार नहीं चले झूठी तुझ बिन मैं आधा हूँ यार तू ही तो करती है मुझको पूरी तू ये जाने ना कुर्बान न पल के भी बिछा दी तेरे आने की उम्मीदों में जान भी जाए ना तू भी आए ना तू क्या जाने सोया नहीं हूँ कितने मैं महीनों में किया था तूने वादा प्यार करोगे हमसे ज्यादा कहाँ गए तुम इस घड़ी में फिर बदला क्यों इरादा सपना तोड़ा क्यों हमारा कट रहा था सब कुछ तो खुशी में तू ये जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों तू आए ना ढूंढता हूँ थक गया पर तेरा क्यों पता न चलता तू ये जाने ना दिल भी माने ना खोया तुझ में इस कदर के बेखबर ज़माना लगता दूर है जाने जा क्यों क्यों तू आए ना ढूंढता हूँ, थक गया पर तेरा क्यों पता न चल रहा। अब दिन से रातों में, सपनों के मुलाकातों में, खुशी बस ख्वाबों में भरा, वहाँ भी आती नहीं, नींद से जगाती नहीं, आंखों से ही तुझको है छुआ। तू जो जाएगी फिर ना आएगी, ना करूँ उम्मीद तुझसे, कहते ना हो हम सफर, मौत ही आएगी यूं सताएगी, सोचते फना हो जाऊं, मेरा होगा ये हशर। तू ये जाने ना, दिल भी माने ना, खोया तुझ में इस कदर के बेखबर जमाना, लगता दूर है जाने जा, क्यों तू आए ना ढूंढता हूँ, थक गया पर तेरा क्यों पता न चलता। नाराना नाराना
Welcome back to another video. Today we are starting linked list. Very important topic for interviews, being asked quite a lot. Linked list is extremely important. Also trees, also hash maps and stuff, and heaps. Sometimes I mean, everything is important, but linked list and trees are like the most important ones, because maybe in your internships or whatever they may not ask you dynamic programming. They may ask you dynamic programming, but they may not ask you, let's say, graph, like big graph algorithms or whatever. They may ask you graphs in like new grad roles or whatever. But linked list is something that's very popular, and in trees as well. So trees has like BFS, DFS or whatever, which we'll learn more about later on. So let's learn about linked list. What is linked list and how we do it. So this video is divided into two parts. The part number one is theory linked list and code of linked list and various types of linked list. Everything you need to know, that is this part. Okay, so we'll cover about singly linked list, doubly linked list, circular linked list, how to add in it, delete in it, use the collection framework, and also create it on our own. So like internally how it works and the theory and time complexity of all these things, and everything will cover. Okay, the second video that will be posted after this is going to be interview questions video that are being asked in like companies like Facebook, now Meta, Microsoft, Amazon, Google, all these other companies. So we'll take questions like this from like the lead code or whatever, and like the previous year questions basically, and we'll try to solve those. Now anyone can solve questions like on YouTube. Anyone can be like, okay, this is how you solve a question, but what we'll actually look into is what is the approach to solve a problem, what type of questions are asked in linked list, and how do you know which particular question to solve in which particular way. So there's like the 2 pointers method, there's like, the cycle detection stuff, middle of linked list. These are like some patterns, very famous patterns. So by the end of these two videos, whenever you look at a linked list question, you will be automatically like, okay, this is the pattern Kunal told us about, apply it, you'll get the answer. So yeah, things like that. In place reversal of linked list, applying merge sort and bubble sort in linked list, that's asked quite a lot. So a linked list is given to you and they're like, hey, apply merge sort or bubble sort or whatever. So recursion with linked list, reversal with recursion and iterations, everything basically that can be asked to you will be covered in this video. So without further ado, let's get started. Make sure you like, share and subscribe, and comment down below if you love the video. But yeah, let's move forward. I'm gonna bring up my whiteboard. What is linked list first of all? So what happens is that before we look into linked list, let's see what are like the limitations or whatever. Arrays, we already covered arrays. So we know that internally in Java, array is not a continuous memory allocation. Okay, we know that. If you don't know this, if you're surprised by this, check out the arrays video. Okay, but in general, we term arrays as like the continuous memory allocation or whatever. Okay, and what happens is, let's say you have a fixed size of array. If that gets full, then you cannot really add new items in that. Make sense? So if you create an array of, like, you can do it right now, create an array of size 5, you try to add a 6th item, it will not be able to do it. It will say index out of bound or array is full or whatever. What is one of the ways to do it then? Something that array list does. So what array list does is something like this. Okay, so for example, you have an array like this and it contains like 5 items, 3, 4, 1, 8, 9 or something like that. Okay, so you contain 5 items, and what happens is that you want to insert a 6th item in array list. What happens? You will double it or whatever internal implementation, it may have something. So let's say it's doubling it. Okay, it will copy all of these, then it will add a new item over here. Okay, so you can see so much not really cool. Okay, it's copying it or whatever, even though it's efficient, even though it's O of 1 amortized or on an average constant time, but still, like, it's not really cool. Okay, it's limiting us. So what's happening is that what we want to do is how linked list works. So linked list basically says that it's not going to be like continuous memory allocation. Okay, this thing will not be like a continuous memory. It will not be like fixed. Instead, try to break these boxes down into separate boxes. Okay, so instead, a box 3 is in the heap or whatever. Box 3 is putting over here. Okay, another box 4 is over here. Another box 1 is over here. Another box 8 is over here. Another box 9 is over here. Something like that. Okay, let's say this is what you have internally. 3, 4, 1, 8, 9. Something like that. Cool. Okay. So how do we make this structure from this structure? What does it work? Okay, you're like, Kunal, okay, no problem. You are now not like having continuous memory. For every block, you are putting it in some random memory. That's fine. Yeah. If you want to add new items, just put it on some random memory because it's not like close to each other as such. Then how are these connected with each other? They are connected via like this. Okay, using these arrows or whatever, which we'll talk more about later. Something like this. If I want to add a new item, it's going to be like, okay, it's not really continuous memory allocation. You can add a new item anywhere in the memory, and then you can point this over here like this. Okay, this is basically what a linked list is. So now the items are not like continuous memory allocation. It's not like index values, index 0, index 1, index 2, continuous memory. No, it's like in different places now. 3 is somewhere else, 4 is somewhere else here, 1 is somewhere else, 8 is somewhere else, 9 is somewhere else, 7 is somewhere else, and they're connected with each other using the pointer that we'll talk more about later. It's not the C++ pointer, it's something else, reference variable, for example. Okay, that's basically how it goes. So what we want to do over here is that what do we want to do over here? We want to see how it works internally. What is this thing? So this particular box is known as a node. Some terms I would like to share with you. So these boxes are somewhat like this in memory: 3 pointing to 4, pointing to 5 or 8 or 1, random numbers, okay, 18 or whatever. This is a normal representation of a linked list. Every single item knows about the next item. It is a singly linked list. Okay, single linked list. Okay, so for example, 3 loves 4. Okay, 4 loves 5. 5 loves 1. 1 loves 18. So this is like a one-sided relationship. Okay, 4 has no idea that 3 has a crush on 4. 5 has no idea that 4 has a crush on 5. 1 has no idea that 5 has a crush on 1. Okay, oh cool. One more thing in linked list that I'd like to mention is a reference variable that is known as head and tail. What is head? Head is actually just a reference variable that points to the very first node. Okay, so in stack you will be having something like this, points to 3. Okay, that's it. And tail will be pointing to the last one. Pretty self-explanatory. Tail will be pointing to the last one. Pretty self-explanatory. Okay, so this individual box, okay, this individual box will have its own type, right? What all things do these box contains? Every single box, what does it contain? I'll talk more about head later. Okay, it's just a reference variable that is pointing to this particular node. Okay, this node itself is a type, okay, of type node. Let's say I say class node. This node itself is a type, okay, of type node. Let's say I say class node. No problem. We've already covered object-oriented programming. Okay, what all properties does this class have? What is a class? Name, group of properties and functions. What does all the properties this every single box have? A value. A box has its own value, like an integer value. Okay, can be anything, but let's say in this case it's a value. Okay, and the next thing is what? What is the next thing? The next thing is to whom it is pointing to, whom it loves. Okay, the next pointer. So here's going to be like, it's pointing to some other node of type node only. Okay, this is a type node, value is 3. It's pointing to another node, another object of type node, value is 4. 4 is pointing to another object of type node, value is 5. Okay, so every single object is going to have this arrow that is pointing to, and it's pointing to what? A node type. So node next is equal to what? Something like that. This is what the representation is going to be of every single box over here. And every single box is known as a what? Every single box is known as a node in linked list. Now if you want to create new ones, and by default this is going to point to none or null or whatever. Do Java or Python or whatever you want to do. Okay, that's it. This is next is equal to what? And it's pointing to what? A node type. So node next is equal to what? Something like that. This is what the representation is going to be of every single box over here. And every single box is known as a what? Every single box is known as a node. In linked list. Now if you want to create new ones, and by default this is going to point to none or null or whatever. Do Java or Python or whatever you want to do. Okay, that's it. This is a structure of linked list. Okay, so one problem over here is what is the problem over here? Problem is you cannot directly access the index. You can't say list.get5, list.get4 or whatever. No, because this only has idea like about like this thing. This will have connection with this. This does not know when the list is ending. List will only end when you reach at last, obviously. Okay, so this has no idea. No one has any idea about how many total elements are there. They have only idea about two things: who is the person that I love, and what is my integer value. That's it. What they know. Every node know only these two things. And what is my they have only idea about two things: who is the person that I love, and what is my integer value. That's it. What they know. Every node know only these two things. Okay, so head is pointing to the first node. So if you want to go, let's say, to the third node, you'll be like, okay, create a temporary node that is over here, point it to head, and run the for loop 3 times. If you want to go to the fourth node, run the for loop 4 times. Something will do, obviously. Okay, sound good? That's it. So this is very simple, just a class node. It has two things. Now most of the theory and code part that we need to look at. So right now we're working with single linked list, head and tail. It's important to know how to work with just the head in the linked list, because tail value makes it easier for us. So for example, sometimes you want to say that, hey, add a new item at the last of the linked list. Okay, something like that. So you can just say, okay, I want to add something over here. I'll create a new node. I'll create a new node like 23, and then I'll say tail.next is equal to the new node that I have created. So to be like, okay, tail.next is equal to the new node that I have created. Okay, the next value is going to be equal to the new node. That's true. So now tail.next is equal to new node, and tail is going to be equal to new node. Inserted in the last in very simple steps. Okay, but if tail was not provided, how will you insert in last then? You would have to first find the last element, traverse till the end. Whenever you find an item that has a next equal to null, it means you have found the last item. Then just add on to it. It's going to take O of n time, obviously, insertion. Okay, but in this way, it's taking O of 1 time only. So taking a separate variable tail makes things easier for us. Okay, in the implementation part, I'll definitely teach you with the tail, because it's like one more variable or whatever, and the theory part is almost same. So when we do questions of lead code, we'll actually do it how lead code wants us to do. Okay, if lead code is providing tail, we'll do tail, but I'm pretty sure they only provide like the head part, I think. So then we'll just use the head part, and we'll do all the questions related to that. Okay, I'll also provide the implementation of without using a tail as well. But first we'll do a tail, and then we'll do doubly linked list, which is something else. So doubly linked list is two-side love like this. You can also go backwards. Here you can only go frontwards. Okay, hope you're able to understand what linked list is. These boxes are just boxes in the memory. Okay, they're pointing to one another using this particular variable. Every box has this variable, and this variable points to the next box. Okay, that's basically what we're doing over here. Cool. So let's move forward. Let's try to code this thing. We have to code a lot of things. We have to code like insertion, deletion, traversal. Then we have to do questions as well. So let's get started. Okay, so we are having a node class. So I can just create a I can rename this as linked list. So we are actually creating internal linked list. Okay, if you want to see linked list in action, like the one that is already provided by Java, you can just check this one. Linked list of type integer list is equal to new linked list. You can create generic ones as well. We have already learned about generics in previous section. So like this, you can use the internal linked list as well. This is fine. Okay, but we want to actually see how this add method is working and all these other things. Okay, how is it actually working internally and things like that. So I'm going to say custom linked list or whatever. Or I'm just going to say linked list LL. That looks good. And I'm gonna remove this main one because I just want to have linked list here. I'll make main separately. Okay, nope. Public static void main, and here we have linked list. Okay, so this linked list is having a class that is node, so I'll make it as a private class node. It has what? It has int value and node next, no problem. So I can say private int value, and then I can say private node next. I don't want it to like point to no, I don't want anyone to access these things directly. That's why I put it as private. Okay, now I'm just going to make a constructor. So the constructor is basically going to contain, let's say, one constructor that only takes a simple value and another constructor, and you know, right, by default what is the value of that the reference of is pointing to when no object is provided? Null, right? But what if you actually provide a null as like a next as well? That's it. Pretty much. That's about it. Cool. Okay. So that's my node. What are the two things that I'm having inside the internal implementation of linked list? So every linked list is having a head and a tail. That is also something I want to make private because I don't want people to access it from outside. Node head, private, node tail, for example. Okay. Let's say I take a size as well. Gonna maintain the size. Okay. Constructor. When I create a constructor, I'm not going to select anything. I'm just going to say this dot size is equal to 0 or whatever. Okay. Cool. Sound good? That's it. Okay. That is it. So whenever you create a new linked list, you can say linked list is equal to new linked list. Now here you can see that what will be initialized. Size will be 0 of this linked list. A head will be there and a tail will be there. Okay. That's it. So very simple. I hope you are able to understand what is this head and tail pointer. These are just pointing to the nodes. Okay, these are just pointing to the nodes. These are the reference variables pointing to this node. That's it. Okay, every linked list is going to have this. The linked list is going to contain this entire thing. It has multiple nodes. Each node will be connected to each other using this thing.
So I'll be starting off with one more playlist, and that is the linked list playlist. But before that, hey, welcome back to the channel. I hope you guys are doing extremely well. So just a disclaimer that this lecture will be super long. Why? Because I'm going to teach you a bunch of things. Yes. And one more thing, I'll not be writing code in C++, nor will I be writing code in Java. I'll try to give you the thought process, the logic, the pseudo code, and you will see while I write the code, even if I'm writing on C++, I'll just make two changes. Yes, I'll just make two changes, and the C++ code will be running in Java as well. And similarly, if you're someone who's using Python or JavaScript, you can also do similar kind of changes, like 1 or 2 lines of changes, and the code will start running in Python and JavaScript. So it doesn't matter which language you're coding in, you can definitely watch this entire playlist. So without waiting, let's get started with the first thing. What is a linked list? Now, till now, you know data structures which store elements. Now, one of the data structures you know is array. So imagine I define an array of size 4. It'll be storing something like 1, 3, 2, 5. It stores 4 integers. Why does it store 4 integers? Because the data type is defined as integer. Now, if in the future I come across and say, hey, can you please add one more element to this array? Like, can you please add 8 to this particular array? Can you add? No, you cannot add. Why? Because the array is of fixed size 4. So if the size is fixed 4, you cannot add one more element. So arrays are of fixed size. Where is the array stored? So there is something as heap memory in the computer, and the array is stored in a contiguous location. What do I mean by contiguous location? And this is the index 0, this is the index 1, index 2, index 3. So the index 0 is followed by index 1, followed by index 2, followed by index 3, and they are in the contiguous location. So imagine if this 0th index is at some memory address 787895, something like this, then this one will be at 787896, right one after. This one will be 97, this one will be at 98. So they are at the contiguous location. So that is why an array is easy to traverse index wise. So you cannot increase the size of the array. At the same time, you cannot decrease the size of the array. So this is where something like linked list comes in. It's a data structure which helps you to increase the size as well as decrease the size. So how does this data structure look like? Now array will be like over here. If I'm defining array as integer, it will be storing integer. What if I define it as double? In that case, the array will be storing double. What if I define it as a list? In C++, the list is vector int. In Java, it is list of int. If I define it as vector or list, what will be like, what will every index store? It will technically store a list at every index. Yes, it will technically store a list at every index, right? So what is a linked list? Linked list is a similar data structure, but the difference is they're not in contiguous location. Yes, they're not in contiguous location. So imagine I ask you to store these 4 elements in a linked list. So what happens is you store 1, you store 3, you store 2, you store 5, but they are stored in the heap memory in, like, it's not a contiguous location. So if I have to draw you, imagine this is the heap memory. 1 might be here, 3 might be here, maybe 2 is here, and maybe 5 is here. So there is no certainty that 1 will be here. 1 can also be somewhere on the right of 2 or somewhere like this. If the memory location of this is 985697 something, this can be anything. So they are not in contiguous memory location. So that is the first thing about linked list, that the not in contiguous location. They can be anywhere. So if they can be anywhere, you definitely cannot go like index 0, index 1, index 2, index 3. And how do you store these elements? Remember one thing, in linked list also you can store integer, double, list, strings, characters, whatever data structure you want to store, similar to array. The only difference is they are not in contiguous location and their size can be increased at any moment. Why? Because array was in contiguous like memory location. So you're not sure if the next, like wherever this was, if the next location is free or not. But when it comes to linked list, there is no next location. It can just, if you add 1 more 6, just find a place in the heap memory and store it. This is the advantage of linked list over arrays. You can increase the size, you can decrease the size. Now the question comes up, how do we store it? So what happens is, over here in an array, it was index 0, index 1, index 2, index 3. And we could easily traverse, right? But how do we traverse? In linked list, we do something different. We are storing element, that's basically the data. At the same time, we store something as next. At the same time, we store something as next with every data. Now, what is next? You need to know. If this is at 0th index, how do you know this is at the first index? Because it is exactly the next memory location. So in linked list, if you know the starting point, if you know this is the starting point, how do you know the next? Only if you can somehow remember where is the next guy in the entire heap memory. If someone can tell you where is this 3 in the heap memory, and it's easy to locate it. So this is how you'll traverse. How will you traverse? Very simple. So for example, let's call it as memory location 1, memory location memory location 2, memory location 3, memory location 4. So basically the first element is at memory location M1. M1 can be anything in the heap memory. Second one is at M2, this one is at M3, this one is at M4. So what we do is, we remember the starting point. Usually the starting point of the linked list is called head of the linked list. Remember this. Usually the starting point of the linked list is called head of the linked list. And the head of the linked list is stored at the M1 location. Remember this. Head of the linked list is stored at the M1 location. Where is the next? The next is stored at M2. So this starting element is storing the next. So what you do is, you basically say next is at M2. So whenever you are starting from head, because you know the head is at M1. So in order to go to the next one, you go to this element and you say, where is the next? He says at M2. So you straight away go to M2, straight away go to that memory location and access that element. So what you're doing is, you're invisibly creating a link. How are you creating a link? You're saying, hey, your next element is this one. Then over here, you're storing your next is at M3. So you're again kind of creating a link. Over here, you're saying the next is at M4. So you're creating a link, correct? Where will this point to? Does it have any new element? I repeat, does it have any new element? No, so there is nothing beyond M4. If there is nothing beyond M4, what you will do is, you'll straight away see null. In Java, it is null. In C++, it will be null pointer. Null pointer. That's it. So what you did was, you stored M2, which is basically, this link will not be created in the heap memory. Just to explain that, you know, from 1, here's the link created. Then there's the link created. And how is the link stored? You just remember, where is my next? If you remember it is at M2, you can straight away jump to M2. And then you know the next is at M3, you can straight away jump to M3. Then you know the next is at M4, you can straight away jump. Then you know the next is null, which means this is the tail of the linked list. What is it called? The tail of the linked list. Tail. Remember this word. It's called tail of the linked list. Okay, so we have understood what is a linked list. I'll not go into the implementation details as of now. I just wanted to give you a context, how to store it. So just imagine someone tells you, increase the size. I want to add 8. How do you add 8? You basically say, put that into the heap memory at some random location M5. Put that into the heap memory at some random location M5. Once you have done this, I knew that the tail of the linked list was at this portion, which is at M4. I knew that the tail was at M4. If I know the tail was at M4, what I'll do is very simple. I'll just go and I'll say, hey, your next is now at M5, which is basically you hypothetically create one more. So just erase it. You create one more, and that one more will store 8. And this next, what that? Use blue color, yeah. The next will be, what will be the next for this? Null, yes, or null pointer for C++. That's it. It is easy to add because you don't have to be dependent on the next memory location. Wherever you find a place, just store it. Again, this M5 can be anything. This is how you can increase the size. I know you can think how to decrease as well. It's very simple to decrease as well. Just remove it. Yes. So, anyways, I'll not go to these things. So we'll talk about that when we do these things. We'll be talking about that. Don't worry. As well. Just remove. M5 can be anything. This is how you can increase the find a place. Just store it. Again, to be dependent on the next. That's it. It is easy to add because you don't have to be dependent on the next memory location. Wherever you find a place, just store it. Again, this M5 can be anything. This is how you can increase the size. I know you can think how to decrease as well. It's very simple to decrease as well. Just remove it. So I've got the concept of linked list. But the next question that might be in your head is, hey, where is it used? So if I talk about data structures, it is used in stack queue. This is the most common data structure that can come to your head. Why? Because what is linked list? No fixed size. And if you know stack has no fixed size. You put on elements, it keeps on increasing. You take out elements, it keeps on decreasing. So stack and queue are primary examples where the linked list data structure is used. You cannot use an array data structure because they're flexible in size. That is where it is used. Where in real life? In real life, we always use it in a browser. Yes, we always use it in a browser. So this linked list that we did talk about was a 1D linked list. What do we mean by 1D? It's just keeping a forward pointer. I'm just remembering what is the next. I'm not remembering what is the previous. So it is in 1D, like it's in one direction. Got it? So basically I remember the next, so it's a direction in 1. I can go from 1 to 3, but I don't know. At 3, I don't know what is my previous one. From 3, I can go to this 2, but I don't know what is my previous one. So it's a 1D linked list. Since I'm talking about real life example, one of the classical real life examples is a browser. Yeah. Let's talk about a browser. What happens in a browser? You open a tab and let's say you search something. First tab you like, this is the first page you landed. You search something, it gives you some results. Imagine you search take you forward. It gives you takeyouforward.org. You go to there. From there, you go to that A to Z course. From there, you go to our article and you do everything in one tab. What are you doing? Initially, it started with search. After that, you went one place ahead. After that, you went one place. After that, you went one place ahead. But on the tab, if you click the back button, it actually takes you back. It again takes you back. It again takes you back. And if you again click the forward button, it takes you front, takes you front. And if you go beyond that something, it again takes you, right? Looks like a linked list. You don't know the size initially. How many things will you be searching? How many things will you be going deep into? And you can always come back as much as you want. You can always go as much as you want. So perfect example where linked list is used. Got it? So the next So perfect example where linked list is used. Got it? So the next question, what is the data structure that we will be using? In order to understand the data structure, we'll have to know about struct and class in C++ as well as in Java. So I'll be telling you about the concept of self-defined objects. So please hear it out properly. It doesn't matter if it is C++ or Java because both of them are identical. So just hear me out in C++. Right after C++, I'll be telling you in Java. Don't skip to Java. Hear the C++ part because it's super easy. So before going into the struct and class concept, I'll write a couple of lines. Int x equal to 2, int star y equal to and of x. What are these couple of lines doing? And if I write cout of y, so basically cout means print of y. What happens? So I'll tell you what happens. This line creates x. This line basically creates x in the heap memory somewhere. In the heap memory somewhere. Stores the value 2. This line, when I say and of x, gives me this memory location. Imagine the memory location is M1. This x is located in the heap memory at some memory location M1. So it will give me M1. That M1 can be anything. It can be any random number. And this is being stored here. So you cannot store a memory location. You cannot store a memory location. So in C++, what you do is you store a pointer to it. You store a pointer to it. So what I know is I have a pointer to this memory location. I have a pointer to this memory location. So if you try to print cout, like if you try to print y, you'll get the pointer to this memory location. Got it? So this is very important. And this is the pointer stuff. Yes, this is the pointer stuff. Int pointer. So this is how you store it because this variable was 2. This thing was an integer. That's why in order to store a pointer to its memory location, you have to give int star. That's how it works in C++. In Java, you just have to store the instance and it's very simple. I'll be coming to that afterwards. What are we storing? If you're defining an array, you're just storing int array of size 10 and it always stores ints, right? Integers. In linked list, what are we storing? Let's scroll up. You're storing the data for sure. At the same time, you're storing the pointer. Please carefully observe. You're storing the pointer to the next, which is basically M2 here. You're storing the pointer to the next. So we're storing two things. One is the data itself. The next thing is the pointer to the next. So I know one thing. My box as of now is storing the data and the pointer to the next. So this is together. If you remember the example, this just has an integer. That's why I could get a pointer to its memory location by saying int star. But if I have two things inside that box, which is the data and the next pointer, data and the pointer itself, which data type is this? There is no data type. This is where you have to define a self-defined data type. So what you do is you go ahead and say struct node star, open this up and then you say int not x data. After that, you're storing a pointer. What is the self-defined data type? Node. The self-defined data type that you're creating, that's called as node. So you are storing a pointer to the next. So node star, because to the next, which is basically the memory location next. That's what you store. And in order to initialize these values, you need a constructor. I'll be explaining you what is a constructor. You write node and you take the data. You can take data 1, you can take next one, okay? And then you say, over here, data's value will be data 1. Over here, you can say, next value will be next one, and then you can close this, and then you can go ahead and close the struct as well. This is how a self-defined data type looks.
That's basically what we're doing over here. Cool. So let's move forward. Let's try to code this thing. We have to code a lot of things. We have to code like insertion, deletion, traversal. Then we have to do questions as well. So let's get started. Okay, so we are having a node class. So I can just create a, I can rename this as linked list. So we are actually creating internal linked list. Okay, if you want to see linked list in action, like the one that is already provided by Java, you can just check this one. Linked list of type integer list is equal to new linked list. You can create generic ones as well. We have already learned about generics in previous section. So like this, you can use the internal linked list as well. This is fine. Okay, but we want to actually see how this add function is, add method is working and all these other things. Okay, how is it actually working internally and things like that. So I'm going to say custom linked list or whatever. Or I'm just going to say linked list LL. That looks good. And I'm gonna remove this main one because I just want to have linked list here. I'll make main separately. Okay, nope. Public static void main, and here we have linked list. Okay, so this linked list is having a class that is node, so I'll make it as a private class node. It has what? It has int value and node next, no problem. So I can say private int value, and then I can say private node next. I don't want it to like point to no, I don't want anyone to access these things directly. That's why I put it as private. Okay, now I'm just going to make a constructor. So the constructor is basically going to contain, let's say, one constructor that only takes a simple value and another constructor, and you know, right, by default what is the value of that the reference of is pointing to when no object is provided, null, right? But what if you actually provide a null as like a next as well? That's it, pretty much. That's about it. Cool. Okay, so that's my node. What are the two things that I'm having inside the internal implementation of linked list? So every linked list is having a head and a tail. That is also something I want to make private because I don't want people to access it from outside. Tail of linked list. So every linked list is having a head and a tail. That is also something I want to make private because I don't want people to access it from outside. Node head, private node tail, for example. Okay, let's say I take a size as well. Gonna maintain the size. Okay, constructor. When I create a constructor, I'm not going to select anything. I'm just going to say this dot size is equal to 0 or whatever. Okay, cool. Sound good? That's it. Okay, that is it. So whenever you create a new linked list, you can say linked list is equal to new linked list. Now here you can see that what will be initialized. Size will be 0 of this linked list, a head will be there, and a tail will be there. Okay, that's it. So very simple. I hope you are able to understand what is this head and tail pointer. These are just pointing to the nodes. Okay, these are just pointing to the nodes. These are the reference variables pointing to this node. That's it. Okay, every linked list is going to have this. The linked list is going to contain this entire thing. It has multiple nodes. Each node will be connected to each other using this thing. Okay, now let's see this in action, like how it works. One question we may have is like, okay, what if you want to like, let me just bring up my white. So let's say you want to do something like this, the very simple stuff. The very basic stuff is, Kunal, right now I don't have anything. Okay, head is not pointing to anything or whatever. It's just null, empty list is available over there. And I want to insert the first item in my list. I want to insert item at the very first index. Okay, I'm saying index, but I'm saying like the very first position, what I would say. Okay, so what do I have to do for that? First of all, you have to create a new node. Okay, node is equal to new node. That's it. Created a new node 3. Okay, sound good? Awesome. That's it. So now not that's it. You created a new node. One thing let me share with you is, let's say you already have a linked list. Okay, imagine you already have a linked list like this. Okay, head is pointing over here, and you want to add a new node at the very first index. You want to add something like 14 or whatever. How do you do? First of all, you create 14. Why do I get these lines? You create 14. Now what do you need to do? In linked list, what I'm going to tell you is that how to solve interview problems and such questions that I ask you, like what to do. Try to draw it on pen and paper and see what is required. Don't see how to do it. See what is required. So now I'm asking you, if you're adding an element over here, like before this you want to add an element, how would it look like? What is like the common sense? And like, I'm not asking you how to do it. I'm saying how would it look like? This 14 internally, if I expand this, it will look something like this. Value is equal to 14. Next is equal to, right now, null. In reality, what should it look like? It should look something like this. If you're inserting an element at the very first index. Okay, so that's step number 1 when solving linked list questions. See, visualize what to do. Okay, now we'll see how to do it. So it's saying this should actually point to this variable, this particular node. And what is this node? Head. So can I not say that this particular node dot next is equal to head? Can I not say that? Isn't it true? Make sense? Okay, so what is happening? Head is actually, let's say, pointing over here to 3. Now what will happen is 14 dot next will also point to 3 like this. Okay, this is linked now, but there's a problem. I told you that head obviously means that the first element of the linked list, but now the head position is now second element. So we have to update that as well. What is the head going to be? If this is equal to node, this is the name is node, let's say. What is the head going to be equal to? I can just say simple head is equal to node. So now my head is going to be equal to node. Sound good? Make sense? Okay. If there was no single element provided, okay, if there was no single element provided, if there was like an empty list, so what would you do? You create a new one. You create a new one. Let's say I create a node like 18. I create a node like this. Okay, I create a node 18, and after that I do something like what is the next step? Head is equal to node. So head was initially what? Null, because 18, 88. If there was no single element provided, if there was like an empty list, so what would you do? You create a new one. You create a new one. Let's say I create a node like 18. I create a node like this. Okay, I create a node 18, and after that I do something like what is the next step? Head is equal to node. So head was initially what? Null, because I did not assign it to anything. You can see in the, when I just said private node head. That's it. So I'll just say head is equal to node. Head will also be available over here. But one thing remaining is tail. Let's say if you have tail also. So if tail is equal to null, then obviously in theory, if there's only one item, that means tail is equal to null initially. And when you add the first item, shouldn't head and tail be equal? If there's only one item, then head will be that only, tail will be that only. So I can say if tail is equal to null or whatever, what tail is equal to head. Cool, sound good? And since I have a size variable as well, I'm just saying size plus plus. That's it. You can calculate the size as well whenever you wanted. You can just start from the head and keep counting till you reach null. Okay, you can do it as well, but I'm doing it in a simple way. Okay, that's it. Hope that clears things up. And it's going to take how much amount of time? Are you running any for loop? Are you running anything like that? No, constant time. Just one single step. Okay, let's try to code this. Okay, so how can I insert? I can just say I'll create a public method. I'll say public void, it's not returning anything. Insert at the first particular like position. I'm going to give it a value. Okay, oops, wrong braces. That's it. What do? I say create a new node first of all. So create a new box is equal to new node, and I'm going to put the value over here. Now I have the new node over here. I want to point this node, the next of this node, to head. So I can say node.next is equal to head. No problem. Now I want to point the head to the newly established node, because head always points to the first node like this. Okay, and then I can say if tail is equal to null, it means that this is the first item being added. So I can say tail is actually equal to head. Both head and tail are pointing to same. Then I can just say size plus equal to 1 or whatever. That's it. As simple as that. Okay. Make sense? How will you display? How will you display? Let's see. Okay. So how am I going to display this thing? I have only been given this head thing. Okay. I've only been given this head thing. So how am I going to display? Can you just say that, hey Kunal, print whatever the head value is, like while, or I can just make it in a new line. Okay. I can say something like while something, let's say head is not equal to your null or whatever, keep printing it. Okay. So you'll just say print head dot value. But there's a problem here. There is a problem here. What is the problem? So if you print head dot value and then head is going to be updated, let's say, okay, you have this 3, 5, 9, 8 or whatever, and this is like, and then null, this is head. It's going to be like, hey, is head equal to null? No, it's not. Okay, print 3. Then head is going to be moving forward. So head is equal to head dot next. Let's say head moves over here now. Okay, head is equal to head dot next. This is actually wrong. Why? I'll tell you later on. This is wrong. Okay, what happens is that when you have started printing it and in the end head will reach over here, your null, and you will be printing all the items. Cool. Sound good? But now you run this function again, the display function. It will be like, okay, while head is not equal to none, print hell. While head is not equal to null, print head dot value. But it's going to be like, hey, head is already null. So you're only able to print it once, and you actually change the entire structure of linked list. Head always is supposed to be at the first element, but after you started printing it, it became in the last. That's why you never move head like this until and unless you're changing the structure of the linked list. When I'm adding a new element, I'm changing the structure. When I'm removing a new element, I'm changing the structure, right? So if you just wanna, if you're not changing the structure, why would you want to move head? Because head actually changes the structure. So what you're going to do is, instead of this, you're actually going to have a new node. You're going to say a new node, temporary node, is actually equal to head. So, head is going to be pointing to this node. And when you say temp is equal to head, that is also going to point to same node. So in the display function, you will have a temp. And that temp, you're going to keep moving forward till it reaches end. Because if it's in the function, its scope is only in the function. It will be out of scope when the function finishes. Already covered in functions video and stuff. Okay, so this is a very important concept of this temp node. So when I say temp is equal to head, it basically is pointing to the same object that head is pointing to. So when you do temp dot next, temp dot next, temp dot next, print, what happens to temp, we don't really care, because temp is not a part of the structure of the linked list. What is a part of the structure of the linked list? Head and tail. Okay, so this is very simple. Take a temporary variable, print do next, print do next, print do next, while it you won't be using a for loop because you don't know how many times the loop will run, so use a while loop. That's it. So this is very simple. Let's code this. Okay, so I can say something like display. It's obviously not going to return anything, so public function not returning anything, display, and it's not taking anything either. Okay, no problem. I'm creating a new node temp that is pointing to head. So changing temp will not change head, because I'm not really like modifying the node. I'm actually reassigning it to next. I'm not saying temp dot something like a temp, just change the value of temp or whatever. No, it's actually just both are pointing to the same object. We already covered like objects and references. So when I do temp is equal to temp dot next, it means the temp is equal to means temp itself is changing to something else, which is temp dot next, then again temp dot next. Okay, so I can say while temp is not equal to null, what do? I can say print temp dot value plus something like this, and then I say, okay, you have printed correct one, move ahead. So now temp is equal to the next value of temp dot next. Are you able to understand what this next represents? This is nothing, it's just this particular next is just a pointer, it's just a reference variable that is going to point to the object that I provided. Okay, and whenever we are adding or whatever, we are actually providing this as a next pointer. So internally it is like this is what links each other, using that diagram that I just showed you. That's it. In the end, I can just say print end, no new line, and let's try to see. I can say list dot add, sorry, insert first 3, list dot add insert first 3, and I'm just gonna say something like 3, 2, 8 and 17. So it's gonna be 17, 8, 2 and 3 when we print it. So I can say list dot display. It should be 17, 8, 2 and 3 and end. (17, 8, 2 and 3 and end. That's it. O of n, where n is the number of nodes. That's how much amount of time it's taking. Okay, so initially temp will be pointed over here. It will be like, hey, is temp currently that it's pointing to okay, so initially temp will be pointed over here. It will be like, hey, is temp currently that it's pointing to, is that equal to null? It's going to be like, no, it's not. Okay, print 17 and print an arrow, and temp is now equal to temp dot next. What is the next value holding for this node? 8. So this is now going to be equal to temp. Okay, so like, hey, is temp equal to null? No, print it. Temp is equal to temp dot next. Is temp equal to null? No, it's not. Okay, print it. Temp is equal to temp dot next. Is temp is equal to not? No. Okay, print it. Temp is equal to temp dot next. 3 is next is obviously null, because by default value is null of every like nodes and complex objects that you have. We've already covered this. Like by default value is null of every like equal to temp dot next. Is temp is equal to not? No. Okay, print it. Temp is equal to temp dot next. 3 is next is obviously null, because by default value is null of every like nodes and complex objects that you have. We've already covered this. Like by default value is null. So it's going to be, yeah, it's null. So it's not going to print anything. It's not going to do anything like that. This will not run, and it's just going to print end. That's it. Cool. This well. So that's how we do it. Okay. That's okay. Now let's look at one more example, which is sort of like opposite to this. So this basically means that what if you want to insert the element at the last particular point? Okay. So you have a list like this. You have like 3, 5, 8, 9, or whatever. This is the head. This is the tail. All right. Cool. So now you want to insert a new item. So you want to insert 17 or whatever. First you would have to create it. So node is equal to new node 17. So this is a node. Okay. Now before actually looking at how do we solve this, we have to see what do we need to do. So in the end, internally it should look something like this. What does this mean? Now see how to do it. So what does it mean? It means that tails next should be equal to the node that I have just created. No problem. Tail dot next is going to be equal to the node that I have just created. Okay. And obviously now the structure is changed. So tail obviously always lies on the left, on the last side. So here tail will lie over here. So I can just say tail is going to be equal to node. Okay. Obviously when this function gets over, the node will be removed. Like not the node will be removed, but this node pointer that is over here, that will be gone out of scope, right? Pretty basic scoping stuff. Okay. Size plus plus. That's it. Okay. And one more thing we want to do is that what happens is that if tail is equal to null, it means that nothing is over there. Then I can just call the previous method that I just said. Okay. I can say insert first value. Cool. That's it. Let's code it. Okay. So I'm just going to say that I need to insert it at the last index. No problem. Public void insert at the last index. So I can say int value. So first of all, what do we need to do? Create a node, create a box. Node is equal to new node value. Now a box is created, but this is not like really connecting with anything. I want to connect it with what? Tail. So I can say tail dot next is equal to node, exactly what I did in the whiteboard. And then I can say tail is actually equal to node. That's it. Size plus plus. But if tail is empty, if tail is equal to null, means list is empty, there is nothing over here. So I can just say call insert first value and don't call the code sample below it. Return it from here. Or you can put it in an else condition if you want. But this just looks much more cleaner. Okay. So that's basically how you can insert an element at the last index. What is the time complexity for this? Constant only. You're not traversing or whatever. So in case you are not maintaining the tail and someone asks you, hey, insert in the last, what would you do? Like this, you will go till this is not equal to null, till next is not equal to null, and then you will just put it over there. Okay, that will take O of n time. So if the interviewer asks you, what is the benefit of taking this extra variable? You can say if you want to insert at the last or whatever, you can definitely do it in constant time. Okay, let's try it. I can say list dot insert last 99. Let's try to print this. 99 should be at the last. Okay, 99 is at the last, no problem. How it works, I just covered it on whiteboard. But what if I want to insert it at a particular point, like a particular index, if you will, at a particular position, like at the 0th position or 1st position or 6th position, nth position or whatever? How do we do that? Let's see. All right, so now the next point is, what if you want to insert it at a particular index or whatever? So you have some random numbers like, a linked list, 3, 5, 9, 8, 12, 18, something like this. All right, now you want to insert it somewhere over here, for example. Okay, you want to insert an element over here. How do we do that? So first things first, if the index given to you is 0, you can just call the insert first method that we just created. If the index is equal to the size, then you can just call the insert last method we created. No problem. Okay. But what if the index is like index number 0, we have 1, 2, 3, 4, 5. If it's, let's say, index number 3, you have to put it at index number 3. Okay, let's say index is equal to 3. In that case, how do we do it? You're going to start checking from here till the index before that. Okay, so you're going to start from here. You're going to, hey, from 1 till less than size. So you're going to go ahead, go ahead, go ahead, go ahead. And then what you're going to do? You're going to say this particular one that I'm currently at this node. Okay, so first thing is just reach behind it. This node, I'm just going to say, hey, so basically what we're trying to do is something like this. Isn't this what we want? 7 like this. Isn't this what we want? Cool. We want this. Now we actually see how to do it. So you go like this, you go like this, and over here you reach. Okay, you reach over here. Then you say node that you're currently at. The next is going to be what? The next is going to be the new node that you have created. Okay. And one more thing you have to do is you actually have to point this to the next of the previous one. So when you update the next over here like this, this path will be removed, right? So how will you do this dot next is equal to this thing? Are you able to understand? So that's what we want to do. We have to store this somewhere as well in temp or whatever. Then I can say new node is equal to temp. That's it. Cool. Let's try to see. Okay, so how do we code this thing? First, we need to go to the previous one like this. But before that, I just need to say that, oops, not that. I just need to say public void just insert a value at a particular index. Okay, something like that. And now I'm just going to say that if the index is 0 means it basically means what? Insert first. So if index is equal to 0, you can just say insert where is insert first? Insert first the value, and then you just say return, and then you can say otherwise if index is equal to the size, then you can say insert last value and return. That's it. Otherwise, what do we do? Otherwise, we have to obviously like start checking from head. Node temp is equal to new, sorry, not new. Start checking from head, and you have to go till here. Whatever the 3 is, you have to go till 2. So if the index is 3, you have to go till 2. Okay, so I can say if the index is 3, you have to go till 2. So if I just put index over here, not starting from 0, I'm going to start from 1, because 0 is this itself, right? And then I'm just going to say temp is equal to temp dot next. Okay, now it will be available over here. It will stop when it reaches behind it. Now I'm just going to say this dot next is equal to the new one that I have created. No problem. So I can say first create a new node. Node is equal to new node, and here I can just pass my value, and I can also pass what is the next value of it. Okay, so you can see this constructor over here, pass the value and then pass the next. Okay, so I can say over here pass the value and then pass next. What is next? Whenever you create this node, value will be 7, next will be equal to what? Next will be equal to current dot next, which is current temp dot next. Able to understand that? That's it. What do I need to do after this? So basically this is what happened. This was sort of like this. You created a new 7 and you said 7, the value is 7, and the next value is automatically what? This node. Actually switch the name over here. So here this is actually temp. So it's temp dot next. Obviously temp dot next. Now just remove this. Temp dot next. Okay. Sound good? So temp dot next is going to be equal to the node that I have created. Okay. Size plus plus. Let's try to see. I can say insert list dot insert, let's say 100 at index number 3. Let's try to print this. So 0, 1, 2, 3. Other things like, index is more than the size or whatever you say, index number 200 or 300 over here, that you can take look at yourself, right? Because you can't really have that much. You can throw an exception over there. We already learned about exception, right? That's it. Very simple. So always try to visualize it and then try to see. Okay. This is more than 2, 100. I get it. So temp size plus plus. Two or whatever you can. That's it. That is it. Okay, let's move forward. Okay, now let's try to delete some items from this. So let's say same thing we'll do, delete first, delete last, and things like that, and delete like from an index also. So delete first is very simple. This is a list given to you. Let's say this is a simple list given to you. How do you delete first? What do we mean by delete first? Delete first
looks like. So what you have done is, let's erase this off. What you've done is, you've defined a self object where there's a data, at the same time there's a next. So this data is an integer, the next is the next pointer, it's the memory where the next exists. So this is self-defined data type. Got that? Now the question arises, how can I, just a second. The question arises, how can I initialize a value? Imagine I've been asked to add a value 2. How can I initialize that? So there are multiple ways to do it. One of the ways is definitely you can say node x, similar to how you do it in a integer declaration, intx, node x equal to, you just call the constructor node and you give the value 2 and you give null pointer, very important, null pointer. So it's basically null ptr. That's what you give. So if you give this, what happens is, this is nothing but a 2 and this is null pointer the next. So you created a variable of your type node, your type node. If you want a pointer to this, you can say node of star y, and this, quite simple. This is how you can do it. But if you just define this, this is just that variable. This is not the memory location. Remember, this is just an object, not the pointer to this one. In order to get the pointer, you have to do node star y. Got it? The easiest way, don't go via this. The easiest way is say node star whatever is your variable name. If your variable name is, let's say y in this case, y equal to, just give this new variable, just give this new keyword and then write new node to null pointer. So what happens is, whenever you define something like this, it automatically stores a pointer to the memory location. So this is how you can do it. Got it? So I jumped into the code editor straight away. I've written the same thing. The only difference is I've defined these things to be public and the constructor to be public as well. After this, what I do is I say node star y equal to new node. Let's say I take the array 0 value, comma, null pointer. If I've taken this, and now I go ahead and say C out of y. See what will happen. I'll just run this. You see this memory location being, like a pointer to this memory location being printed? Got it? So you understood the new keyword, right? It directly gives you the memory, like a pointer to the memory location, and then you can store it. But what if I define it like, I don't use the new keyword, and I define it like this? So what technically over here you're doing is just creating an object where these two things are there. Array of 0, which is technically 2, and null pointer. These two things are there. So if you now try to print C out, it throws you an error because it's an object. You can either take data from it and then print it. So if you take data, it'll print 2, or you can take the next and you can print it. So if I print the next, it's basically the null pointer. That's how you do it. Got it? In case I would have defined it as this, add a new keyword. In that case, I cannot print this. Y.data will be giving me an error. I have to do something like this, and it will be printing me the 2 value. Got this thing? So technically use this. I did tell you about the other thing because the concepts have to be clear, but technically just use this. A new keyword, and you can straight away do this. And in a lot of declarations, you'll find that, hey, they'll be writing something like this as well. They'll have multiple constructors where they just have the data 1, and they might have multiple constructors as well. Why multiple constructors? What if I just don't want to pass null pointer again? So what they do is they say new node array of the element, and it automatically assumes it to be null pointer. So you might have multiple constructors. So constructor is nothing, it's just a special type of member function, which is used to initialize the objects. If you see, these are the objects of the class. Of the class in the sense, self-defined object. Okay, so this is how you define a struct. Now with struct, you don't get the object or the element, and it automatically, I just don't want to pass null pointer again. So what they do is they say new node array of the element, and it automatically assumes it to be null pointer. So you might have multiple constructors. So constructor is nothing, it's just a special type of member function, which is used to initialize the objects. If you see, these are the objects of the class. Of the class in the sense, self-defined object. Okay, so this is how you define a struct. Now with struct, you don't get the object-oriented programming concepts like abstraction, encapsulation, inheritance. You don't get these concepts. But if you have to use these kind of data structure in industry, you need to have object-oriented programming. This is where what most of the people do is instead of struct, use class. Even if I use class, it's going to work in the exact same manner. Let me quickly run this off. So if I still run it, it still prints me 2, right? Why? Because it's the same thing. Struct only doesn't offers you these extra things like the object-oriented programming concepts. With class, you get this benefit. That is why always define, like whenever you're taking self-defined objects, always take class. And you'll see that in the coming lectures in graph series, we have something as disjoint set data structure, and we have used self-defined object. Over there, we've defined it as class, not as struct, and it has helped us significantly. So this is how you can do it in C++. So this is about C++. Now, you might be thinking, hey, but we are Java people. How to do this in Java? So in Java, there is no concept of pointers. There's no concept of pointers. So what I'll do is, I'll straight away take you to the Java code. So let's quickly go to the Java code. And over here, I'll copy the same thing. Let's quickly copy this, class node. And over here, the differences will be, I'll remove the star. Yes, I'll remove the star from everywhere. And this will become this dot, because in order to access the class objects, we have to do this dot, so that for that object, it can directly initialize. And this one will be null instead of null pointer. How many changes did I do? So basically, okay, by the way, you cannot define public because it's already by default public. No need to define it. How many changes did I do? I remove the pointer. The null pointer becomes null. Has the same concept. How do you define it over here? You don't give pointers. You say node of y equal to new node of, let's say, array of 0. You can either give null or you can leave it because you have multiple constructors. So I'll just leave it. And now I can give system.out.print and I can straight away print y. In C++ we wrote this. In Java it will be dot and your data. So if you write y.data and if I just run this, maybe I'll take array of 4 so that, okay, no, array of 4 is not the array of 3. Let's take array of 3. You see 8 is coming plus. You see this? Right? 8 is coming. So what are the differences? There's no pointer, and in order to access it's dot. That's the only difference in Java. I copy pasted the exact same code. So going forward, trust me, if I'm writing C++ code, converting that into Java code is like just removing pointers and replacing this thing with dot. That's it. That's the only change that you have to do. I'll be showing you throughout the course how easy it is to convert a C++ to a Java and vice versa. So C++ has struct and class, but Java has only class. Remember this? This one is done as well. And the question arises, what about the memory space? throughout the course, how easy it is to convert a C++ to a Java and vice versa. So C++ has struct and class, but Java has only class. Remember this? This one is done as well. And the question arises, what about the memory space? So let's talk about what things are you storing. It depends on it. So as of now, we are storing a data and a pointer. That is what we are storing. And the memory space will depend on the system. Imagine I'm operating on a 32-bit system. In that case, the integer will take 4 bytes and the pointer will take 4 bytes. I will summarize to 8 bytes. Whereas we are storing a data and a pointer. That is what we are storing. And the memory space will depend on the system. Imagine I'm operating on a 32-bit system. In that case, the integer will take 4 bytes and the pointer will take 4 bytes. I will summarize to 8 bytes. Whereas if it is a 64-bit system, the integer will end up taking 4 bytes, whereas the pointer will end up taking 8 bytes. So depending on the system, the memory location might take more. In that case, it will be 12 bytes. That will be the memory space. Is it important? No. I'm just telling you, just know about it. The memory space. Is it important? No. I'm just telling you, just know about it. Done. That's why I just ran through it quickly. Depending on the system, the memory space used might be different, as well as what if I'm storing one more thing, int age. If I store one more data in it, and I'm telling that, hey object, please store one more information with you. In that case, you'll have to add +4, and it will become 12, and so on 16. So depending on what you are storing, you have to analyze manually. Perfect. This one is done as well. I think I've explained the difference between node and node star, right? Pointer. I've explained this. So this is also done. Now we come up to the main thing. How do we convert an array to a linked list in C++ or in Java? It's a very simple thing. It's a very, very simple thing. I'll just be talking about the logic here, and then I'll be writing the C++ code. I'll be copy pasting and making the changes I told, and I'll be running in Java as well. So let's assume we are given this array which has 2, 1, 3, and 8. We're given this array of size 4. What do we need? I always told you that we need to remember where is our head. We will have this node self-defined data type where we can store all the data. Initially, we define the head. So what we do is we go to the heap memory and use the new keyword and create this data type where we store the 2, which is array of 0. And at the same time, we say the next pointer. So what I'll do is I'll always point the next pointer like this. It's pointing to null. Null is basically x as of now. So this is something which you will create for the first variable. I'll do it for the first variable. I've done it for the first variable. So where is my head pointing? Head is always pointing to this defined data type where we remember. Let's assume we are given this array which has 2, 1, 3, and 8. We're given this array of size 4. What do we need? I always told you that we need to remember where is our head. We will have this node self-defined data type where we can store all the data. Initially, we define the head. So what we do is we go to the heap memory and use the new keyword and create this data type where we store the 2, which is array of 0. And at the same time, we say the next pointer. So what I'll do is I'll always point the next pointer like this. It's pointing to null. Null is basically x as of now. So this is something which you will create for the first variable. I'll do it for the first variable. I've done it for the first variable. So where is my head pointing? Head is always pointing to this. Remember this. Head is always pointing to this. So what I can say is, I'll erase this. My head will always be this. Always. You will never ever forget head, because if you forget head, you don't know where's your starting point. So you have to keep a track of it. Keep a track of it. And now what I'll do is, I'll take a variable mover. You'll understand why am I doing it. It's very simple. I'll take a variable mover. I'll go to the next index, which is index 1. And I'll start iterating for index 1, index 2, and index 3. Basically, apart from the first element, because first element will always be head, I start iterating through every other element. That is what I'll do. So I iterate through this element. So I need to store it in my data type. So I'll again create node equal to new node and put this. So what I'll do is I'll put this into some, data type where the next is always null. Where is my mover as of now? Where is my mover as of now? Over here. And imagine this is my temporary, which is created. The temporary I've created. I've gone here. I've created a temporary by calling new node of 1 null. So this is created and this is now pointing to null. In order to create the linked list, what should happen? Create this into some, I'll put this into some data type where the next is always null. Where is my mover as of now? Where is my mover as of now? Over here. And imagine this is my temporary, which is created. The temporary I've created. I've gone here. I've created a temporary by calling new node of 1 null. So this is created and this is now pointing to null. In order to create the linked list, what should happen? This previous element, instead of pointing to null, it should remember that its next is this. It should remember the pointer to this memory location, correct? This is basically mover. So can I say, mover, your next will be temporary? Because if you remember, how will we create temporary? Node star, temporary, new, node, and the variable 1. That's how we'll create. The temporary is already a pointer to this. So this temporary can be assigned to this. Can be. So if I write this, what will happen? Instead of pointing here, this will start pointing here. Perfect. Once you have done this, don't move ahead, don't move ahead. Move this mover to this portion. And your temporary can be just forget about temporary. Next. This is done, you move to this 3. Let's do the same thing again. I'll create 3 and this will point to null. I'll create 3 and this will point to null. Correct? And this will be my temporary. But this is connected to this. This has to be connected to this. What will I write? The movers next will be temporary, isn't it? So what will happen? This will no more be pointing to this and it will be pointing to this. Quite simple. And once I've done this, I'll take the mover and I'll move it ahead. Afterwards, I move ahead to this, which is 8. So let's again create 8 in a temporary. So temporary will now go to the next implemented. Again, what thing will happen? The mover instead of pointing to null will start pointing here, and this is definitely pointing to null. Done. After this, the iteration is over. what we have done is, we have created a link to all the nodes I created. I created all the nodes while traversing, and I then attached them. So at the end, the mover will be moved here and will stop here. Can I say, since I stored the head, I know my starting pointer to the memory location. I know the pointer to this. I know that this is there because head is storing a pointer to this first node. I know where it is. So one thing that you need to remember in the questions related to arrays, they're always asking you to return array or something like that. In questions related to linked list, you cannot return the entire linked list. So what they will ask you is to return the starting point, and then they will be traversing it on the backend. But they will ask you to return the starting point. Got this? So let's quickly get back into the code editor and write the code. I'll be writing the C++ code. In case you're someone who is doing it in Java, Python, JavaScript, doesn't matter. Understand the C++ code because in the Java code, there's a slight change. In the Python code, there's a slight change, and I'll be showing you that. Don't worry about that. So what's this code? After that, I'll be writing this Java code. Do not worry. And in the links, you'll be finding the Python and JavaScript code as well. So what do we need to do? We need to convert an array to a linked list. That's what we need to do. So we'll be taking a function which will be taking this array. What do we need to return? I told you we cannot return the entire linked list. So we technically return the head. What is head? We need a pointer to the head. That is what we will be returning, right? So can I say the head will always be the first element, which is array of 0. Since I have a multi-constructor, I don't need to pass the null pointer. It will always be doing that for me. What is the next step? I need a mover, which initially points to head. So the mover is standing in the first place. Perfect. Done. What's the next thing? Let's iterate. We skip the first element, which is the 0th index, and we go till the last. So let's go. What after this? We'll be creating we'll be storing this value, stored in temporary. What is the next job? I need mover. So next, because I need to create the link. Next, to point to this temporary. And after that, I need to move, because mover, if I go back over here, this temp was created. I had mover here. It pointed to this. After this, the mover has to go ahead. The mover has to go to front, to the next one. So either you say mover go to your next, or you say mover equal to temp, because it's the same thing. Because temporary is it. It's the same thing. So either you say mover equal to temp, or you say mover equal to mover dot next. Same thing. Once you've done this, can I say everything is done? And you can straight away return the head. So imagine I say node head equal to convert, and I pass on this array, and then I try to print the head's data. You will see that it is converted. I'll also be telling you how to traverse, don't worry. If I try to print this, you see 2 is printed. If I just change it, make it 12, you'll also be seeing 12, right? So very simple. So let's quickly copy paste this and go back to the Java editor. Inside the class, you can paste it. The first thing is remove all the pointers. Let's quickly remove all the pointers. The next thing, remove this one to dot. What is the next thing? This will be length. Remove this. This vector will go as int array. We need to have a private static, otherwise you'll have to create an object. Okay, looks like, yeah, everything is done. What's the next thing? Node of head equal to convert, pass on the array, and then try to print it. So I'll print head of data, not head of 0. Okay, let's try to print it. 12 is printed. Wow. Same code, same logic. Just remove a couple of things, starts working. What is the time complexity? Simply traversing. So bgo of n. Yes, you traverse through every element and you store it. That will be the time complexity. So array to linked list is done. What is the next thing? Traversal in linked list. Now you store it. That will be the time complexity. connected to this. What will I write? The movers next will be temporary, isn't it? So what will happen? Be this always. You will never ever like forget head, because if you forget head, you don't know where's your starting point. So you have to keep a track of it. Keep a track of it. And now what I'll do is I'll take a variable mover. You'll understand why am I doing it. It's very simple. I'll take a variable mover. I'll go to the next index, which is index 1. And I'll start iterating for index 1, index 2, and index 3. Basically, apart from the first element, because first element will always be head, I start iterating through every other element. That is what I'll do. So I iterate through this element. So I need to store it in my data type. So I'll again create node equal to new node and put this. So what I'll do is I'll put this into some, I'll put this into some data type where the next is always null. Where is my mover as of now? Where is my mover as of now? Over here. And imagine this is my temporary, which is created. The temporary I've created. I've gone here. I've created a temporary by calling new node of 1 null. So this is created and this is now pointing to null. In order to create it as of now. Over here. And imagine this node equal to new node and put this. So what I'll do is I'll put this into some, I'll put this into some data type where the next is always null. Where is my mover as of now? Where is my mover as of now? Over here. And imagine this is my temporary, which is created. The temporary I've created. I've gone here. I've created a temporary by calling new node of 1 null. So this is created and this is now pointing to null. In order to create the linked list, what should happen? This previous element, instead of pointing to null, it should remember that its next is this. It should remember the pointer to this memory location, correct? This is basically mover. So can I say mover, your next will be temporary? Because if you remember, how will we create temporary? Node star, temporary, new, node, and the variable 1. That's how we'll create. The temporary is already a pointer to this. So this temporary can be assigned to this. Can be. So if I write this, what will happen? Instead of pointing here, this will start pointing here. Perfect. Once you have done this, don't move ahead, don't move ahead. Move this mover to this portion. And your temporary can be like, just forget about temporary. Next. This is done, you move to this 3. Let's do the same thing again. I'll create 3 and this will point to null. I'll create 3 and this will point to null, correct? And this will be my temporary. But, this is connected to this. This has to be connected to this. What will I write? The movers next will be temporary, isn't it? So what will happen? This will no more be pointing to this and it will be pointing to this. Quite simple. And once I've done this, I'll take the mover and I'll move it ahead. Afterwards, I move ahead to this, which is 8. So let's again create 8 in a temporary. So temporary will now go to the next. Again, what thing will happen? The mover instead of pointing to null will start pointing here, and this is definitely pointing to null. Done. After this, the iteration is over. What we have done is we have created a link to all the nodes I created. I created all the nodes while traversing, and I then attached them. So at the end, the mover will be moved here and will stop here. Can I say, since I stored the head, I know my starting pointer to the memory location. I know the pointer to this. I know that this is there because head is storing this. Head is storing a pointer to this first node. I know where it is. So one thing that you need to remember in the questions related to arrays, they're always asking you to return array or something like that. In questions related to linked list, you cannot return the entire linked list. So what they will ask you is to return the starting point, and then they will be traversing it on the backend. But they will ask you to return the starting point. Got this? So let's quickly get back into the code editor and write the code. I'll be writing the C++ code. In case you're someone who is doing it in Java, Python, JavaScript, doesn't matter. Understand the C++ code because in the Java code, there's a slight change. In the Python code, there's a slight change, and I'll be showing you that. Don't worry about that. So what's this code? After that, I'll be writing this Java code. Do not worry. And in the links, you'll be finding the Python and JavaScript code as well. So take this. Can I? And how do you see? Remove all the a private static. Remove this. Paste it. Very simple. So let's quickly copy paste this and go back to the Java editor. Inside the class, so you can paste it. The first thing is remove all the pointers. Let's quickly remove all the pointers. The next thing, remove this one to dot. What is the next thing? This will be length. Remove this. This vector will go as int. the array, we need to have a private static, otherwise you'll have to create an object. Okay, looks like, yeah, everything is done. What's the next thing? Node of head. Equal to convert, pass on the array, and then try to print it. So I'll print head of data, not head of 0. Okay, let's try to print it. 12 is printed. Wow, same code, same logic. Just remove a couple of things, starts working. What is the time complexity? Simply traversing. So big O of n. Yes, you traverse through every element and you store it. That will be the time complexity. So array to linked list is done. What is the next thing? Traversal in linked list. Now this is very, very important, because if you understand how to traverse in a linked list, you can literally do everything. So traversal is something that you will have to learn, because even if you remember the array problems, you always traverse in an array. So similarly in linked list, in all the problems, you'll have to traverse through the entire linked list. How do we traverse? So once the array is converted to a linked list will look something like this. Again, it will be somewhere in random memory space. We will always have the head. And what is the head pointing to? The starting head of the linked list, the starting of the linked list. And as I said you, never ever tamper the head. That's the first rule of linked list. Never ever tamper the head, because if you move the head from here to here, you forget which is the starting point. Who will remember it? So never ever tamper the head. The first thing I'll do is, I will take a temporary variable which is also at head. Tell me, what do I need to print? 2. How can I print this? That's basically temp of data. If I do this, it'll give me the value 2, correct? But after that, I need 3. How do I get 3? I'll have to take this temp to here. How can I take this? We have the next stored. Just go to the next. After that, I'll have to take 1. Again, go to the next. After that, I'll have 8. Again, go to the next. After that, the temp will reach at a moment null. The moment it reaches null, is stop. So can I say, if I have to implement this, it's probably, I'll just take the code editor and write it. It's going to be super simple. Node start temp head, because I don't want to tamper my head. Node start temp equal to head, while temp not equal to null, or maybe you can just say while it is valid. After this, cout temp data and this, and then temp will move to the next. So let's move to the next. Let's try to play it. So if the entire array is printed, done. If I have to show you in Java, now you will appreciate me that, hey, it's very, very easy. So just take this, instead of this, I'll just say temp.data and probably do a plus this, and instead of this, I'll write this, and I'll just take this, and while this is not equal to null, because in Java, okay, perfect. Let's try to, should be perfect, yeah. Let's try to play it. Simple. It's easy. The C++ Java codes are same. So you don't have to think about it. So next one, length of a linked list. How can you find a length of a linked list? Imagine you're given a linked list and you'll have to find out a length. Can I say private or maybe length of LL? And always you'll be given the head. So node star head will be given to you. What do? You take a counter 0, you copy paste the traversal. Yes, you just copy paste the traversal. And inside the traversal you give a counter plus and you can return the count. That's it. That's how you print the length. So if I have to print the length, I can simply say cout length of the linked list. Oh my bad. Length of the linked list and head, and I can go ahead and run this. Finally, yeah, should be good. I don't need to print this. I can omit this off, and if I print this, the length is 4. Perfect. Super simple. Again, Java. Guys, do you need Java code now? Isn't it easy? This, remove this, do this, done. Is it that tough? Okay, let's take system.out, otherwise I'll have to write this. And the linked list head should be good. Right, let's run it. My bad. Let's run it now. 4 done. Quite simple. I just remove 2 things and the Java code also runs. So let's take the same code and we'll go to the code studio and copy paste here and try to submit it. Let's see if one time submission works. It will. So it's pretty easy, isn't it? So the length of a linked list is done. It will be taking a bingo of n time complexity. The next thing, search in a linked list. I think most of you can do it. So what is the question? Given a linked list. So whenever it is said that you're given a linked list, you'll always be given the head of the linked list and given an element. Tell me if that element exists in a linked list or not. So search or check if present. So you'll be given, yes, you'll be given the head and you'll be given the value that you have to check for. One thing is for sure, you always copy paste the traversal. So please copy paste the traversal. Never ever tamper the head. So how do I check? Can I say at any moment if temp dot data equal to val, I return yes, which is 1, or else I return 0 at the end if the entire traversal is complete. Quite simple. Can I write this? Probably I'll just remove this and I'll say this check if present, and I'll probably pass on the head and I'll ask them to check for S5 there. Let's see. Let's try one. Oh yeah, it is there. Let's say 15 is there. No, it's not there. So this is running. So the next thing I'll do is I'll take this code and I'll copy paste in Code Studio. Why am I running in Code Studio? Because the environment in your coding rounds or your online assessments will be similar. It'll just be given the function. It'll not be given this int main or these things. You'll have to understand. So over here, you're seeing that it's slightly different. It's saying the type name, the template is slightly different. So whenever there is something like t, which means you define it, it can be integer, it can be double. Like over here, they're defining it that it will be integer. So this is how you write like global template that can be reused for anything. If I write it as int, I can only use it for int, but if I write it for t, I can use it for string, arrays, anything. This is how you write it, got it? So if you run this, this will not run. You'll have to specify over here like this, yes. You'll have to specify over here, otherwise it will not run. And this is k, so let's do it k and try to submit it straight away. So these are the things, that is why I'm using compilers, something which are similar to online assessment, so that you understand how the questions will be asked. What is the time complexity? Obviously, we go off n at the worst case in case the element is not found. We go off n at the best case in case the element is the head itself. And the average will be n by 2 in case it is somewhere in between or somewhere like that. So this is also done. So you're still left with deletion and insertion. We'll be doing that in the next lecture. In case you're still watching, please do consider giving us a like. And if you want all the codes, you'll be finding the links in the description. I'll be adding the So let's continue with our playlist, but before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So I'll be solving the problem, reverse a given linked list. So you'll be given a linked list and your task is to reverse that particular linked list. So imagine you're given this particular linked list. If I try to reverse it, the reversed linked list will look something like this, right? So your task is to return me the new head of the reversed linked list. Now, if this problem comes up in an interview, what is the extreme naive solution that you can think of? Like, I can think of, what if I take all of these elements out, right? That's the first thing. Let's take all of these elements out. We need a data structure to store it. So maybe I'll take a data structure stack. Why stack? You'll understand why after I take it out. So first, let's stand at the head of the linked list. So I'll take a temporary variable because we do not want to alter the head. It might be used afterwards. So what is the first data? 1. Let's take it and put it into the stack. Right after that, let's move temporary to the next. What is the data? 3. Let's take it, put it into the stack. After that, let's move it into the next. Take the data, put it into the stack. After that, let's take the next data, which is 5, and put it into the stack. After that, move the temporary, and eventually you will reach null, which means you have traversed the entire linked list, right? Once you have done this, let's do our next step. So the next step is, again I'll take temporary and this time I'll place it on the head again. This is the reason I did not alter the head. So this time when I'm standing at the head, what is the data? The data is 1, but if you're reversing, the 5 should be here, isn't it? How do you get this 5? You look at the stack, and stack is something as last in, first out. So what is the last entered element? 5. So if you do stack.top, you'll get this 5. You'll get this 5. This is why I took something as stack. So you'll take this 5 and what you'll do is you'll replace this. Done. After this, you'll move the temporary to the next one. Again take the next one, which is 2. Replace the data. After that, again move to the next. Again take the top at the stack, which is 3, and replace this. After that, again move to the next. This is 5, take 1 and replace it. After that, you will reach null. The moment you reach null, you will observe a couple of things. Your stack, the stack you took is empty, and at the same time, your linked list is reversed in terms of data. Now this is very important. You have reversed the linked list, but just in terms of data. So can I write the code for this one? Probably yes. So this algorithm will be in 2 steps. One is traversal, putting everything into the stack. The second is taking out of the stack and putting back to the linked list. So let's do the step 1. Can I say the step 1 will be, I'll take a temporary and put it at the head. I'll also take a stack. So assume your stack is named as ST. Again, depending on your language you're using, you can code it across. Let's do the traversal. So the traversal will go on till I don't reach null, right? What's the first step? Put it into the stack. So stack.push or stack.add, depending on your language. Take the data and put it into the stack. Once you have done it, ask temp to move to the next. So temp will move to the next, which is basically temp of next. So this is the step 1 of the algorithm where we are taking all the data and putting it into the stack. What is the step 2? Taking back from the stack and putting it into the linked list. So let's do it. So I'll again reassign temporary to the head. And this time what I'll do is, I will again keep it moving till it reaches the last, which is null. Okay, let's do it. So what we say is, temporary, your data should be replaced by whatever is on the top of the stack. Once you have taken the top, depending on your language, if your language needs stack to pop it out, so basically you delete the top element. It's required in some languages, it's not required in some languages, depending on the language that you're using. And after that, move the temporary to temporary next. So this will be the brute force, and can I say this will be the step 2. So 2-step algorithm, rather a 2-pass algorithm. What will be the time complexity of this algorithm? Can I say this is bgo of 1 and this is another bgo of 1. So in overall, the complexity will be bgo of 2n. What will be the space complexity? It will be bgo of n because you're storing all the elements into the stack. So this will be the time complexity, and the space complexity. This is where the interviewer will not be happy with this one. That is basically the space complexity, and he'll ask you to optimize it. This is when we move on to the optimal algorithm. So the previous algorithm was using an external space. What we need to do is we need to optimize that external space. What that means is you cannot use any external data structure, which means we have to play around with the links. That's the only way. So if I'm reversing the linked list, it technically means this one will be the new head of the linked list, right? So can I say if I'm reversing it, then if 1 stays here, 3 stays at the same place, 2 stays at the same place, 5 stays at the same place, at the same memory, data is same, and this becomes my new head of the linked list. I've reversed it. So this will be my new head. So this new head of next will be pointing to 2, 2's next will be pointing to 3, 3's next will be pointing to 1, and 1's next will be pointing to null. Correct? Am I right or not? I am, right? We need to somehow find out a logic such that these links are reversed. Let's observe. If I take this particular node, which is the node having the data 2, the 2 is basically this node has the data 2 and the next is pointing to 5. What we need to do is the data stays intact. We need to make sure this next points to the previous one. So I'm basically changing one link. If you look at every node, let's look at every node. The node with 1, I'm changing this node. The node with 3, I'm changing this node. The node with 2, I'm changing this node. The node with 5, I'm changing this node. Somehow, I'll have to play around with the next and make it point backwards. This is what I have to do. Can I do this? Let's try thinking. So what I'll do is, I'll just take one node just to understand. So this one node has a data. Let's call it some data. It's pointing to the front and it definitely has a previous element. All of us know it. What is the task that we need to do with one node? That's basically taking this and pointing it to the back. Imagine you have the previous node. Just imagine you have the previous node. How can we do it? So there's the node which it is pointing to, right? And we can call it as the maybe something as front node. Yeah. So just assume you are standing at this particular node and this node is called as temporary. What we technically need to do is temporary next should be pointing to previous. This is something we have to do, which will mean this node will be pointing to back, right? Next job that I have to think is, hey, wait, if you point this, how can you go to the next node? Because we have to somehow do the same thing for the next node as well. How can I go to the next node? So what you will do is, before replacing this, just make sure you store the front node. So you say temporary dot next. So what I've done is I've stored it. After that I do the step. So this step is performed after storing. So what happens is now this is done. What is the next job? The next job is technically moving the temp to this. Just think out loud. It is. So can I say temporary can go to front? And if I just look at the larger picture, this will again be pointing to someone. I'll again have to do the same job of rotating it back. I'll again have to do the same job. So thereby I need this previous. So I need to make sure I am preserving this previous. So what will happen is I'll say preserve or rather previous. I'll have to preserve it. So before moving, make sure previous is temporary. So what I did was, let's recall what I did. So basically previous was here, temporary was here. So what I did was I said previous, since it is done, the rotation of the pointers is done. Previous, you can go ahead. So this line will do it, right? After that, I'll say the next line. So the next line will take it forward. And then again, you're on the same cycle when you can do the same job, right? You can again make sure the same cycle is repeated. So what I'll do is, I'll try to do this algorithm Rather, I'll try to do a dry run. Let's do it. So what I'll do is I'll write while temporary, let's do it till it reaches null. Very simple. What are the steps? What I can do is I can straight away copy this steps. Let's say copy, and after that let's over here paste. So I'll just paste the same code over here. Done. Let's try to do it now. So I have to perform this algorithm for all the nodes, right? So what I'll do is I'll start off with this particular head. So can I say temporary will be head? I can. Afterwards, what can I say? I know one thing. After the reversal, this one will be pointing to null. This one will be pointing here. This one will be pointing here. And this one will be pointing here. I know this. So I need to make sure this first node is pointing to null. So maybe I can take a null and I can call it as previous. So I'll take a previous and I'll call it as null, right? Let's do the step. What's the first step? Front. So let's assign front here. So this step is done. What is the next? Temporary dot next equal to previous. So what happens is this temporary dot next is pointing to previous. Nice. What is the next? Previous equal to temporary. So previous goes to temporary. Perfect. What is the next? Temp equal to front. Temp goes to front. Perfect. So this is one step. This is one step. So we are done with one step. What is the next step? Let's again do the same thing. Front equal to temporary. So front goes to temporary dot next. Right? What is the next? Temporary next previous. So basically what happens? Temporary is next, which is this I'm erasing, goes to the previous. Perfect. What is the next? Previous equal to temporary. Goes here. Perfect. What is the next? Temporary equal to front. Goes to next. Perfect. So I'll just erase this and erase this as well. Done. Let's do the next step. Front equal to temporary next. So front goes over here. Perfect. Temporary next. Previous goes next equal to temp. Let's take then and there. And if you carefully see, temporary would have reached null, right? So this while loop will end. This while loop will end. What is the new head of your linked list? Previous. So you can go ahead and return previous because that is your new head. Done and dusted, isn't it? So let's quickly get back into the code editor, and as you can see, I've written the exact same code. I'll hit the submit button and it will be working fine. Again, the same code can be submitted in Java as well. I'll go to Java and over here I'll paste the same code. It's the exact same thing. What you just need to do is need to change this pointers and then this one to dot, and this goes in lower caps. Perfect, and should be good. Let's quickly, okay, this one will also be lower caps. Let's try to run this off and see if it is running fine. Should be. It does. Let's quickly submit it. So it will be running fine. So it is running absolutely fine. Now coming back to the code. Changing the links. So before I start off with the recursive solution, please make sure that you would have seen my basic modules of recursion. In case you haven't seen it, I'll be leaving the link in the description. Go back and watch it, understand what recursion is, and then you can understand this particular problem. What is, like, why is recursion used, or how do we use recursion? And this goes in lower caps. Perfect, and should be good. Let's quickly, okay, this one will also be lower caps. Let's try to
Hi guys, in this video we are going to discuss with you one topic, that is how to find out in order, pre-order and post-order traversal of a tree. Okay, binary tree. So suppose we are taking one example. This one is
हेलो अभिषेक भाई, तुम्हारी आवाज़ धीरे आ रही है। हाँ, अब सही आ रही है। ये स्कोपो भाई, इसको खुद तो आता नहीं, मेरे से चीटिंग कर रहा है और फिर वहाँ पे आंसर डाल रहा है और अपनी रैंक बढ़ा रहा है।
हेलो।
हाँ, आ गया। अरे भाई, मैं कह रहा था कि देख, इसके अंदर ना मेरे को मतलब ये एग्ज़ाम्पल देख,
क्या चीज़?
इसके
कौन सा
अंदर
एग्ज़ाम?
अबे कोई सा भी देख ले, तीनों में से।
हाँ।
अब इसके अंदर इसने ना सारी फ्रीक्वेंसी देख, जैसे पहले वाले में ना फ्रीक्वेंसी सबकी 2 कर दी इसने, लेकिन दूसरे वाले में फ्रीक्वेंसी 2, 3, 4 अलग-अलग है, तो वो नहीं समझ आ रहा।
अरे रुक।
अबे ये के का तो समझ गया कि सही उस इंडेक्स वाले एलिमेंट को अपन को वो करना है।
We can make two by deleting one occurrence of A and one occurrence of D. Therefore, the word becomes this, where B is this. अबे देख, आइडिया ये है ना, तू देख इसका रीजन क्या बता। क्योंकि
बता।
देख 2 है, K2 है, राइट? तो अगर मान लिया, अगर मैंने A को छोड़ दिया होता यहीं पे, ठीक है, A को मैंने रिमूव नहीं करा, A पड़ा है, A का फ्रीक्वेंसी कितना है? 1 है, एक बार occurrence है इसका। और D कितने बार है? D मतलब इसको भी नहीं हटाया मैंने, कितने बार है? 5 है।
एक एक
अगर मैं
मिनट
दोनों को बीच में माइनस करूँगा,
एक
डिफरेंस
सेकंड।
निकालूँगा।
मम्मी, नाना का फ़ोन आ रहा है मेरे फ़ोन पे, लो।
और अभिषेक भी आ गया। हेलो, हेलो। हाय भाई। बोला भी कर कुछ यार, पता ही नहीं चला। मैं कॉफ़ी लेने गया था। आ गया क्या सहज वापस? लग ही रहा था। इतने सारे
अभिषेक का
एक्टिविटी
तो आ
आ
गया।
गए उसके अचानक से, मुझे लगा
अभिषेक
आ
का
गया
तो
होगा।
वायर आ गया होगा।
क्या चीज़?
अच्छा, अच्छा, नाइस, नाइस।
अरे आ
हाँ,
गया।
बता, समझा, क्या बोल रहा था? k = 2 वाले का?
अरे देख, सिंपल आइडिया। अगर मैंने नहीं करा, डिलीट नहीं करा, ठीक है? कुछ भी डिलीट नहीं करा। 1
हाँ,
एक बार है, A एक बार है, D 5 बार है। अगर मैं इन दोनों का डिफरेंस निकालूँगा तो मेरा K, अगर डिफरेंस निकालूँगा तो कितना आएगा? 1 माइनस 5 कितना होता है? 4 आएगा।
रहेगा।
तो वो K से एक्सीड कर रहा है ना, ये नहीं होना चाहिए। इसलिए है ना, उसने A को रिमूव कर दिया और D में से भी 1 रिमूव कर दिया। उससे क्या हो रहा है, अब इतने बचे हैं, सिर्फ़ इतना माल बचा है।
अच्छा, इनका
अगर
अच्छा
मैं इसको माइनस करूँगा तो मेरे को कितना मिलेगा? 2 मिलेगा। इन दोनों के बीच में करूँगा 1 मिलेगा। इन दोनों के बीच में करूँगा तब भी 1 मिलेगा। तो मुझे वो
तीसरा
बस
एलिमेंट।
इसको कंट्रोल करना है कि जो माइनस करके जो भी आ रहा है वो K से बराबर या छोटा होना चाहिए। यस।
एग्जांपल।
एग्ज़ाम्पल क्या?
अबे 3 एग्जांपल भाई।
सेम है, क्या डिफरेंस है?
इसमें तो
एक
अगर तू अभी इसमें तू फ्रीक्वेंसी देखेगा तो 6 आएगी ना?
बी हटा दिया ना उसने,
हाँ, तो
बी
ए
उड़ा
बचे।
दिया उसने। अब बस एक ही तो बचा।
हाँ, तो एक ही बचा, तो उसकी फ्रीक्वेंसी तो 6 हुई ना, लेकिन
हाँ, तो क्या हो गया?
कुछ भी
बट
खुद
जब
को
दूसरा बंदा है ही नहीं, जब
कुछ
दूसरा
भी
बंदा है ही नहीं।
खुद को नहीं समझ आ
अरे
रहा
तो
तो
ये ना क्या लिखा है, वी कैन मेक द वर्ड too special by deleting B, therefore the word becomes equal to A, where each letter का फ्रीक्वेंसी इज़ फॉर्म यूनिफॉर्मली 6। हाँ, तो देख अबे सुन, अब एक-एक लेटर का कितना है? 6 है ना फ्रीक्वेंसी। अब मैं ए को ए से माइनस करूँगा, कितना आएगा? 0। ए से ए को करूँगा वापस -0। उससे
चल
कम ही
चल।
तो है ए। तुम भी ना
अबे वो
यार,
ए से ए
बकवास ही
माइनस
करते हो।
नहीं करना, अगर तेरे पास ए है ना, तेरा
ए का
0 से
फ्रीक्वेंसी से एक अबे क्योंकि अबे नहीं, ये देख रहा है तू?
मेरा तो सुन।
आई और जे चलाना है तेरे को।
हाँ, यही बोल रहा था मैं।
हाँ, नहीं, मैं भी वही कह रहा था तेरे से।
अबे लेकिन तू 1 काउंट कर रहा है ना, वो 6 माइनस 6 होगा हर बार। 1 माइनस 1 नहीं
अरे
होगा।
भाई, वही तो बोल रहा हूँ मैं। मैं
हाँ,
कौन-सा फ़ारसी बोल रहा हूँ।
ठीक है ना भाई, ठीक है।
तो स्पून फीड करूँ हर चीज़ में।
अबे मैं तो बता रहा था भाई तेरे को, मेरे को लगा तू गलत समझ के बैठा है।
नहीं,
अभिषेक आ गया, चल पुट पार्टी खेलते हैं।
पुट पार्टी काफ़ी टाइम हो गया। अब यार उसको भी बुलाना तो फिर, वो खेलता है कॉलनिस्ट।
आयुष, अबे
क्या कर
इसको
रहा है वो
कौन
आजकल?
याद है ना कॉलोनिस्ट।
क्या चीज़? इसको आ गया भाई, इसने सीख लिया, ग्राइंड मार लिया इसने, टेंशन ना ली तो।
आज तो वैसे भी वो है, सेमीफाइनल है वैलोरेंट में।
अरे भाई, कल का मैच पीआरएक्स और इसका वुल्फ का, भाई साहब! मतलब
तूने वो देखा था
वन साइडेड था।
पीआरएक्स
क्या
वर्सेस
मतलब?
देखा था क्या?
पीआरएक्स वर्सेस किसका?
टीम लिक्विड भाई, पीआरएक्स
अबे तेरा वॉइस ब्रेक हो रहा है भाई, क्या माइक लगा रखा है तूने?
माइक लगा के रखा, मैं तो स्पीकर पे हूँ।
अरे भाई वो फैन भी चल रहा होगा साथ में।
हाँ हाँ, चल रहा है तो वो सुन कि पीआरएक्स के 12 थे और टीम लिक्विड के 3 थे, ठीक है।
ओ हो मैंने देखा भाई। जो इतना हार्ड हार्ट ब्रेकिंग था ना, वो हार्ट ब्रेकिंग क्या बोल रहा हूँ मैं, बेचारे उनके लिए। भाई 1-12 से कितना कितना था स्कोर, कितना था स्टार्टिंग में?
12-3 था, 12-3।
11 12-3 12-3
मीठा है नहीं वो। हाँ, 12-3 था।
12-3 थोड़ी तो था, 10-3 था, 10-3 होगा यार, 9-3 या 10-3 कुछ था शायद।
अबे पहले तो
राउंड पहला
11
पहला राउंड के बाद।
11 था। अभी 11-1 तो नहीं, सॉरी 10-2 था, 10-2 था। फिर उसके
हाँ
बाद में
वही तो
वो
10-2 था।
भी जीते थे।
फिर भाई लगातार एक मैच और जीती, एक और राउंड जीती, फिर लगातार सारे जीतते गए भाई लिक्विड। भाई क्रेजी था भाई। मैंने देखा था, पूरा मैच देखा था बैठ के मैं। काफी बढ़िया था। पिपिप पिपिप पिपिप।
ये कहाँ गया?
अभिषेक। अभिषेक।
चला गया लग रहा है।
नहीं नहीं, यही बैठा होगा। कॉल आ गया होगा। चलो।
कुड बी। कल तो फाइनल है, पीआरएक्स वर्सेस फेनेटिक, होपफुली।
फिनिट।
मतलब आज जो जीतेगा वो होगा ना, आज फेनेटिक वर्सेस वो।
ओ लास्ट दो G2 और इसके बीच में कौन जीता?
फेनेटिक जीते ना 0-2।
अच्छा शिट यार।
भाई एकदम क्लोज क्लोज चल रहा था और लास्ट में फिर
मैंने
फेनेटिक ही
देखा ही
जीत।
नहीं वो मैच, बट मुझे मुझे तो वो ज्यादा अच्छी लगी थी वैसे। G2।
देखो जीटू
G2
बढ़िया,
वाज बेटर।
फेनेटिक बढ़िया लगती थी भाई।
फिनेटिक ठीक है।
वो बहुत ही तगड़ा होगा कल।
the tree, and we are going to find out in order, pre-order and post-order traversal of this tree. See, in order means left, root and right. In order traversal, if you want to traverse this tree in order fashion, then firstly you would traverse left, then you would right root, and then you would go to right part. in मतलब बीच में, in या अंदर आप बोल सकते हो, तो root would be in between left and right part. pre मतलब पहले है, in that case इस यहाँ पे क्या होगा, traversal root then left and then right. and what is post order? post मतलब बाद में, तो it would be left, right and root. okay, in मतलब root would be in between left and right. pre का मतलब सबको पता ही है, पहले मतलब root सबसे पहले आएगा, then left and right. post का मतलब होता है बाद में, तो root बाद में आएगा, पहले क्या आएगा, left then right then root. okay, now see what is in order traversal of this tree, this binary tree. ठीक है, we would start obviously from the root of the tree. यहाँ पे आप A से start करोगे. ठीक है, in order में क्या होगा, पहले left part traverse होगा, then root then right. so हम यहाँ से चलेंगे, ये है आपका रूट. आपको रूट नहीं लिखना है, आपको सबसे पहले क्या ट्रेवर्स करना है, लेफ्ट पार्ट, तो आप इसके लेफ्ट में आओगे. ठीक है, अब यहाँ पे आप चेक करोगे, ऑब्वियसली इसका ये लेफ्ट है, बट यहाँ पे इसके लिए ये तो रूट है ना. ठीक है, हमें रूट नहीं लिखना, हमें फिर से क्या लिखना है, लेफ्ट पार्ट लिखना है. आप इसके लेफ्ट में जाओगे, लेफ्ट पार्ट में कुछ है नहीं, नल है लेफ्ट पार्ट. ठीक है, सो आफ्टर दैट यू वुड प्रिंट रूट मतलब आप बी को प्रिंट करोगे. ठीक है, रूट के बाद क्या प्रिंट करोगे आप, यू विल गो टू राइट पार्ट. राइट में क्या है, डी. ठीक है, आगे कुछ नहीं, आप पीछे जाओगे, बैक टू बी से बैक गए, आप ए पे गए. ठीक है, दस ए का ये है आपका लेफ्ट पार्ट, ये लेफ्ट पार्ट है वो ट्रेवर्स हो चुका है ए के लिए. ओके, नाउ लेफ्ट पार्ट ट्रेवर्स हो चुका है, तो रूट लिखोगे, मतलब आप ए को ही यहाँ पे लिखोगे. ओके, नाउ यू वुड गो टू द राइट पार्ट, दिस पार्ट, राइट वन, राइट पार्ट. सी, बट फॉर दिस राइट, इसके लिए ये राइट पार्ट है, बट दिस इज सब ट्री ना, बिकॉज इनके लिए ये क्या है, रूट है, तो आप इसको डायरेक्टली नहीं लिख सकते हो. ठीक है, रूट से पहले क्या आएगा, अपना लेफ्ट आएगा. अब ये रूट है इनके लिए, तो आप इसके लेफ्ट में जाओगे. ओके, अब ये भी इसके लिए रूट है, तो आप इसको डायरेक्टली नहीं लिख सकते हो, आप इसके भी किस में जाओगे, यू विल गो टू द लेफ्ट पार्ट. लेफ्ट में क्या है आपका, जी. इसके बाद देखो लेफ्ट में कुछ नहीं है, तो यू विल प्रिंट जी. ओके, लेफ्ट वुड बी प्रिंटेड. लेफ्ट के बाद आप बैक ट्रैक जाओगे, रूट प्रिंट करोगे, मतलब ई को प्रिंट करोगे आप. उसके बाद आप जाओगे राइट में कुछ नहीं है, देन यू वुड प्रिंट नथिंग. ओके, नाउ बैक ई से आप वापस जाएंगे यहाँ. सी, इस रूट के लिए ये क्या है, अपना लेफ्ट पार्ट. लेफ्ट अगर आपका पूरा हो गया, आफ्टर दैट व्हाट वुड बी प्रिंटेड, रूट, मतलब सी वुड बी प्रिंटेड. आफ्टर दैट राइट पार्ट वुड बी प्रिंटेड. सी, ये है इसके लिए, दिस वन इज राइट पार्ट, बट यू कैन नॉट डायरेक्टली प्रिंट एफ, बिकॉज एफ रूट है यहाँ पे. एच और आई के लिए दो उसके चिल्ड्रन है, तो ये आप इसका रूट हो गया. रूट को आप डायरेक्टली प्रिंट नहीं करोगे, रूट से पहले लेफ्ट प्रिंट होता है, तो आप इसके लेफ्ट में जाओगे. एच के लेफ्ट में कुछ नहीं है, तो आप क्या प्रिंट करोगे, सीधा एच. देन एच प्रिंट हो गया, उसके बाद लेफ्ट प्रिंट हो गया. लेफ्ट के बाद क्या प्रिंट होता है, रूट. बैक जाओगे आप, रूट है आपका एफ, और एफ के बाद क्या प्रिंट होगा, दैट इज आई, राइट वन. So left, root and I. This is the in order traversal of this tree. Okay. Now what is pre-order? After that, now देंगे A को. रूट के बाद क्या प्रिंट होगा, लेफ्ट. यहाँ पे आप किसी रूट तो जाओ में जाओ, उसके बाद रूट सी जी ट्रैक गए, उसके बाद आई लेफ्ट राइट कुछ नहीं है, देन एच वुड बी प्रिंटेड. देन रूट लेफ्ट, उसके बाद दिस इज नाउ वी वुड डिस्कस दिस पोस्ट ऑर्डर रिवर्सल ऑफ तय बाद में, तो रूट सबसे लास्ट में आएगा, पहले लेफ्ट पार्ट देन राइट पार्ट देन लास्ट में है डी, ठीक है। बी नहीं कर वन नहीं कर नॉट लेफ्ट, ठीक है, प्रिंट नहीं ना। सी का रूट है रूट ऑफ, बट ये रूट एफ, ओके, लेफ्ट प्रिंट राइट। आई होप यू